Yes, guys, welcome again. And yes, last class we have been discussed about what exactly we mean by a finite automata. And last class I just explained how exactly to represent the automata by taking a small example of sheep talk teller machines. I hope everyone are clear about that. And let me go further about what do you mean by automata and what are the types of automata we have and a different kind of thing. And today I'll be explaining one type of it. Yes, to starting with, whenever I say about a finite automata, whenever FA comes, FA stands for a finite automata. Okay. Whenever we say about something called a finite automata, there are two types of finite automata, two categorized of finite automata. What we have, one is a finite automata with output, a finite automata without output. The thing is like output and without output. Like when I explain the things in detail, you guys will come to know what do you mean by with output and without output. Currently, you feel like we have been categorized a type of automata into two categories. One category we name it as a with output category, and one more category we name it as a without output category. Whenever we tell about with output category, there are two types. One is More and Mealy machines finite automata, More model and Mealy model. These are two types of model or two types of machines we have in with output finite automata machine. When you come to a without output finite automata machine, there are three types of automata machine. What are the three types? One we say as a DFA. Whenever we say as a DFA, DFA stands for deterministic finite automata. DFA stands for deterministic finite automata. What do you mean by deterministic? As the name says, an English meaning of a deterministic. Deterministic, something will be defined. For example, I will come to know what will be happen next. This is called as a deterministic. In other words, like this is a scenario where I will be coming to know. For example, deterministic meant to say, whenever I write any exam, I can determine such that I can pass or fail. It's called as a deterministic. And the next one is an NFA. NFA stands for a non-deterministic finite automata. A non-deterministic finite automata means I can never determine what will happen next. Like I'll be in ambiguity what I'll be doing. For example, there are few students like who always says who come out of exam, they say, sir, this subject, it was a chill relax, like I can score very good, better one. That's called a deterministic. Okay, like I can determine what will be happening as soon as I come out of exam. And non-deterministic meant to say there are few people who says, sir, I've written something, I don't know, I might pass or I might fail, the subject was difficult. This is called a non-deterministic, and there's something called as epsilon NFA. Epsilon stands for an epsilon, a non-deterministic finite automata. Epsilon meant to say epsilon non-deterministic finite automata. Non-deterministic finite, okay. Let me compare the same thing with respect to exam again. Non-deterministic, okay. Epsilon NFA, we say like there are few people who say like, sir, I don't know, sir, I have written only the questions in exam paper, but I don't know how come I got been passed. That's called an epsilon NFA kind of people. I hope you guys are clear about this terminology. Okay, whenever we come out a finite automata with output, there are three types. One we say DFA, deterministic finite automata, like a student's coming out of exam, he feels like yes, I am passed and I can get 80, 90, 70. Non-deterministic finite automata, I mean, like students come outside and they might say that, sir, I don't know, I might be pass or I might be fail. I meant to say two ambiguity comes. This is called a non-deterministic. Epsilon NFA, there's few set of people who say like, sir, I haven't written anything and I have been passed. This is called as an epsilon NFA. And I will make a note, I haven't written anything, like I have not done anything and I have been passed. This is called epsilon NFA. I'm sorry, this is just an example what I am telling. This is not the case with respect to a motion. I just want you guys to remember the terminologies and hence I have been done up with that things. Clear? Okay, now I'll be explaining something called as a DFA. DFA stands for a deterministic finite automata. DFA stands for a deterministic finite automata. Whenever we say about deterministic, I think as I've been saying, like the output will be properly determined, how exactly the given output works and what will be done. A definition of a DFA the definition of a DFA says a machine M is equals to K sigma delta S and A. The definition of DFA says a machine M under machine. A machine M is equals to K sigma delta S A. Sir, what do you mean by this? Simple guys. Like I'll take an example. I hope I can solve it in an easy way. Okay, let me define what do you mean by K. K equals a number of states in a machine. What do you mean by K? K stands for a number of states in a machine. Like hope you remember last time when I said about an example bar, BAAA with exclamatory. There are 5 states. Q0, Q1, Q2, Q3 and Q4. That is called as states in a machine, and K stands for a number of states in a machine. And I hope everyone know what you mean. Sigma is a number of symbols used. Number of symbols used. Clear? And a delta is a transition. Delta stands for a transition where Q cross sigma, which implements Q. This thing I'll be explaining with an example later. Okay, delta, just think there's something called a delta. Delta stands for a transition. Transition means to say, in an English terminology, I'm transferring from one state to another state by using a symbol, and that's called as a transition. And this one I'll be taking an example and then I'll be explaining. S stands for start state and A stands for end state. Okay, S stands for start state, A stands for end state, and this what is a definition of a DFA. Let me repeat again for you all. The thing is that a DFA has been defined as a machine M. A machine M is equals to K sigma delta S A. K sigma delta S A. It's called as a 5-tuple machine. Okay. K stands for a number of states on a machine. Sigma stands for a number of symbols used in a machine, and delta stands for a transition. Delta stands for a transition. S stands for a starting state. A stands for an ending state, or the last state, or a final state. Okay, this what is a definition of it. Okay, so this is a definition I know, like how to know you mean by a DFA, how to write a DFA. Before telling that, I'll just tell you a simple thing about a DFA. DFA is a machine where it will be easily represented or easily built by using a language. I take any language, easily built a machine is called as a DFA, where a DFA will be built very easily. And one more thing we have to keep one in mind is DFA has a very less memory. DFA has a very less memory. These two things are the key things. Like, why do I have a less memory and a remaining thing? When you go further, I think I can explain you that in detail. Okay, let me take up one example and explain you and define the given thing. Okay, first and foremost, to take up an example, guys, simple thing. Let me go with an example. Clear? Okay. An example which you all know, and that example is I'll take something called as an L. L stands for language. A language is a set of strings. The set of strings done which starts from A, where the symbols are A, comma B. Is that clear? This is a question. Guys, you might ask, is this a question we asked in exam? Yes. Similar type of questions will be asked in exam. Okay. This is construct a DFA. Construct a DFA for the given language which accepts a set of a string which starts from A. Clear? Okay. Whenever this question is being asked, we have to think one thing in mind. The first step for me is I will start listing the probabilities of my output. I will start listing the probabilities of my output. What do you mean by probabilities of an output? It's simple. As the question says, I'll start listing an output. I meant to say what will be my output. Andre, given string says it exactly starts from A. Andre, will that be an epsilon? Null irutta? No. If and all I want to reach my output, A is mandatory. Andre, it should be only minimum at least one A. So I write A. Clear? And next probability is, can I write AA? Yes. Two strings, a string AA, it has to start from A. I don't mind. What later? And can I write AB? Yes, I can write AB because the string starts from A. I don't mind what exactly goes later. Can I write BA? Can I write BA? No. Why I can't write BA? The reason behind it is the string, this is one string. This one string should start from A. But it is starting from B and hence I can never write BA. Can I write BB? No. Again it's starting from B. And hence the length 1 done, length 2 done, length 3. Can I write AAA? Yep. Can I write ABA? Yes. Can I write ABB? Yes. Can I write BAA? No, I can never write. Why? Because the string starts from A. Okay, this is a given thing. Clear? And this continues. This continues. This is infinite. That continues. The question is, it has to start from A. Okay, now this is my first step which I have been done. Let me go with my second step. So what is my second step? My second step is right. We have to write a diagram. We have to write a diagram. How to write the given diagram? It's a simple bit. I think everyone knows the single circle, double circle, arrow mark, and a transition. I hope you guys remember that. Based on that, I'll be writing an exam. Okay, first and foremost, I take something called as a Q naught. And Q naught is a starting state. Blindly, because a mission should start from a state, and hence I am taken Q naught. Now, I've been listed out the probabilities of a given string. I've been listed out the probabilities of a given string. In this probabilities of a given string, and now I will think which is the bare minimal probability. Andre, which is the least string which has to be accepted from a machine. So, don't you feel this is the least string which has to be accepted from a machine? Least string. Okay, whenever I say least string, it has to accept 1A. To accept 1A, what it should be? I'll go from Q0 to Q1. I'll write accept an A. Clear? I'm Q1 or not? To Q1, accept it. Don't you feel at least 1A has been accepted? To make that accepted, what I do? The state called Q1, I make this as a final state. A state called Q1, I make it as a final state. Now, Ivaga. The thing, I'll start tracing at last. As I've been explained, this is a tape. Okay, I'll write only one A. A string is true or false, it has to be set by a compiler or a machine. How it says? It has to accept the string and it has to be in a final state. Hence, I can say yes, it's been true. Now, I will accept A and I will just check whether I'm in a final state or not. When I accept A, am I in a final state? Yes. And hence the string is true. Correct? Okay, now, sir, I've been done with this. Next, the next is AA. A and A. So, what I have to do for A and A? Don't you feel a simple logic what I have been explaining in the previous class? Can I write like this? Because my given question says it has to start from A. It can be 3A, 4A, 5A, 6A, 7A. It's an infinite A's. And hence, infinite in a word bandaga, can't I use a loop? Perfect. I have been done with that. Is that clear? Okay, now, given question A is been done. What about AB? What I have to do for AB? AB. Can I write A comma B? Can I write A comma B? What do you mean by A comma B? Simple is either A or B is acceptable. For example, A, I'm in a final state. A, B, I'm in a final state. A, B, 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 I'm in a final state. And hence, this is a given diagram for the given question. I mean to say, this is a given machine. This is a given machine for the given language L with set of string contains A in it. Is that clear, guys? Yeah. If so, I'm not done with a DFA again. This is just my second step. My third step says design a complete DFA. My third step says design a complete DFA. And just for your convenience, I'm rewriting again, but it's not necessary to rewrite it. Okay, what do you mean by the things again? I repeat the third step. This is a Q0. This is a Q1, which is a final state. Here it's A, and here it is A comma B. Okay, now what do you mean by a deterministic? Deterministic meant to say I'm in a state called A. Whatever the symbols are present, all symbols should have a transition. Clear? Each and every state there should be each and every symbol used, and this is called as a deterministic. For example, I'll tell you, I'm in a state called Q0. I'm in a state called Q0. Have I used the symbol A? Yes. State Q0 only. I use A. Am I going to next state? Yes. Perfect. Done. I'm in a state called Q0. Have I used the symbol B? So this is called, it's not been deterministic. So here I have to use the symbol B and I have to say yes, now a state called Q0 is been determined. In a state Q0 or in one state, all symbols must be used. Either it can be an infinite loop, or either it can come to a same state, or it can go to a next state. Anything is possible. So now here, can I write here as sir Q0 A Bardaga? I'm going for a state called Q1. It's perfect, sir. And if I use a state called Q0, and if I use a symbol B, where I have to go? This is my question. Okay, where I have to go with symbol? A should reach a final state. AB should reach a final state. What about BA and BB? If I use a string called BA and BB, where I have to go? The string is false. I should be in non-final state. It should not be a final state. Clear? So what I do at this scenario, I use another state called a Q3 state. I use another state called a Q3 state, and I send B to that. Clear? And I send B to that. If I use A, I'm in final state. If I use A, B, I'm in a final state. If I use B, A, B, A, and hence I write here as an infinite of A comma B. So you are try B, A. The string is wrong and I'm in a non-final state, correct? B, B. The string is wrong and I'm in a non-final state. If I'm in a double circle state, it's called as a final state. If I'm there in a single circle state, it's called a non-final state. And hence, the machine is correct. Okay, let me check with Q0. Q0 ge A, B, yellow. Now it's correct. I'll go with Q1. Have I used both symbol A and B? Q1 on A, correct. Q1 on B, it's correct. And hence, for the things, both are correct. Is that clear, guys? Okay. Now, let me go with the next one. Okay. And for Q0, it's been determined. A and B is been done. For Q1, it's been determined. A and B is been done. And for Q3, it's been determined. A and B is done. And hence, this diagram, I'm going to say, this machine is a DFA machine. This machine is a DFA machine. Is that clear? Okay, now next. Now, sir, I've been designed a machine a step, but I have to define everything. I have to define everything. So how to define everything? Okay, it's a simple way to define the given machine. I'll be using a machine M is equals to K sigma delta S and A. Immediately I should start listing it. How to list the given thing? What is a K? K is a number of states in a machine. How many states I have? 1, 2 and 3 states. What are those states? It's a Q0, Q1 and Q3. Is that okay? It can be Q2 also, never mind. Never mind, it can be anything. Okay, Q0, Q1 and Q2. Clear? And next there's something called a sigma. Sigma, you know, number of symbols used to design the given machine. What are the symbols which we have been used to design a machine? It's A, comma B. Clear? And next, what is the next? It's called a delta. Delta is a transition. What do you mean by a transition? It is a simple language, guys. A delta on state. I'll take first Q0 comma A. What is the output? I'm in a state called Q0 and I use a symbol called A. Where am I going? I'm going to Q1. Here, I'm in a state called delta. I use a Q0 on B. Where am I going? If I use Q0 on B, I'm going to Q2. A delta Q1 on A, delta Q1 on B. Q1 on A, I'm going to Q1. Q1 on B, I'm going to Q1. Yeah, okay. A delta of Q2 comma A, I'm going to Q2. A delta of Q2 comma B, I'm going to Q2. Correct? Simple way. Q0 on A, Q1. Q0 on B, Q2. Q1 on A, Q1. Q2 on B, Q2. And this what you mean by a transition. Is that clear? This what is mean by a transition. And the next thing is I will be writing something called S. S is a starting state. Which is a starting state for a given S? S is a starting state where here I'll be using something called S. The given S starting state is, the starting state for S is Q0. So the starting state is Q0. A is a final. The final state is A. Q1. Clear, guys? And this what is a starting state and a final state. And this is what you mean by a finite state machine.